Okay, so right here we got the knapsack problem without memorization is this top one up here. So we're going to start with the 40, which is the max weight we can carry. We're going to have our first call, which is going to use I1 in this case, which is 25 pounds. And then we're just going to keep going down each one of these till we find the most efficient way of packing the bag, basically. So in this case, we're calling with 25 first, so we're taking 25 off of the total weight, which give us 15. And then since we have 15 here, we have two ways of breaking that down, which is either using I2, which is 15 pounds, which gives us a remainder of 0, or 10 with a remainder of 5. How I wrote the program is anything less than 10 pounds will automatically return 0, since there's no items that would basically fit. So in this case, we're going to return 0 for both of these. So it'll be I2 plus 0, and then I3 plus 0, and then we'll choose the maximum out of those two values. So in this case, it would be 9. We'll return 9 up here. Then we're going to add our I1 value, which would be 10, giving us a total of 19. Then we'll be going down the second one, which we're using I2. So we're going to take 15 off of 40, so we'll have a 25. And then we're going to do a very similar process, and then we're just going to, like in this case, since it's 25, we can take 25, 15, or 10. So our first instance is going to be taking 25, which will give us a remainder of 0 and a value of 10. Second one would go down, we'll take 15 out, gives us a remainder of 10, and then that will continue down, giving us a remainder of 0. And then in this case, we'll use I3, remainder of 15, and similar, exactly the same as this one. We'll take that 9 value, pass it up here, and with this one, we're going to add up, since we took 10 off in this instance, the monetary value would be 8, so we're going to return 8 up here, add that to the monetary value of I2, so that gives us 17 right there. These both add up to 17, so we'll just choose one of those and return that up to I2 plus, in this case, 17, which would give us 26. And then in this instance, we're breaking it down using I3, which is the 10-pound one. So we're going to break that down, get that to 30. And then again, similar to this one, since we can use all three values, we're going to do that where we have 25 taken off with the remainder of 5, as well as breaking it down with 15 and then 15 down, exactly the same as this. Or we're going to take 10 off again, which would give us 20, and then break that down again, which would give us 10. In this case, in each instance of this, we're just going to take the max value between the two, or 3. We're going to add those up, and then we're just going to keep taking the max one. So in this case, this one returns 8. Since it's the only one, we're choosing that one. We're going to add 8 to this one, which would be another 8. So we have 16, and then it would be 16 compared to 9. We would take 16 over top of 9, and then pass that up, and then rinse and repeat for each one of these options. And then in this case, it would all break down to basically being 4 item 3s, which would give us 32. And then this is the pseudocode I wrote for it. So in this case, we're passing an array for the values and the weight, as well as our total weight. And then in this case, we're doing if n is less than or equal to 0, or it's less than any weight we basically have. In this case, this is assuming that the weight would be, like the least amount of weight would be at the end of the array, like in this instance. And then in any of those cases, we'll just return 0. We're setting max v to the lowest number we can. And then similar to the cut rod problem, we're just going to be going with a for loop. And then while we're in there, we're going to make sure that our weight is like our weight is greater than n. And if that's the case, we're going to add to I, which would just push it. So like in one these type instances. So like, since we have 15 here, we can't use 25. So assuming 25 is index 0, index 1, index 2, say we're looking at 25 initially, we don't want to look at 25 because it's too big. So then we're just going to switch it and then move to the next one. In that case, it would be 15. And this is the recursive call. So we're just getting the max. Excuse me. We're getting the max for max b, and then we're adding value index I plus our recursive call, which our recursive call is just going to subtract the weight of the selected item from our total weight, and then those two arrays will stay the same. And then at the very end, we'll return that.